Okay, just like we have the chain rule, and we have the quotient rule, and we have the product rule, and all these rules are used to kind of help us take derivatives of it, of a function. Well, what this lesson's all about is what to do is learn the steps on how to take a derivative of an equation when your dependent variable is not to the first power. You know, our dependent variable is always that variable that when graphed, it's on the vertical axis. If it's in the form of y equals like 2x plus 3, our dependent variable is the y. Okay, and everything up to this point, all the derivatives that we've done, all of the y's have always been to the first power, or all the f of x's have always been to the first power. And so what this lesson focuses on is what to do when it's not to the first power. And that's where we get the concept of implicit differentiation. Okay? And let's go through the first example, and I'll just kind of walk you through it on how to do it. You probably saw above on exactly what we're talking about, but this is how you're going to do it step by step. Okay, so we want to take the derivative of this equation with respect to the x variable. And a lot of times we've been kind of ignoring some of the notations, and you're going to see why here. But if I take the derivative of x cubed, it's technically, we just say 3x squared. But really after that, what we're doing here is taking the derivative of the x with respect to x. That's what we should have been writing every single time. But dx over dx is just 1, so we don't write it. To kind of help us see what's going on here, let's go to the next term. So we want to take the derivative of y cubed. Well, the derivative of y cubed then would be 3y squared, and we're taking the derivative of a y variable with respect to x. Okay, so dx because we're taking the derivative of an x with respect to x, and a dy dx because we're taking the derivative of a y with respect to x. And let's go over to this right side. Well, we got 18, and now times the product of xy. So we've got a product rule where it's going to be first times the derivative of the second, which is just 1 dy dx, plus the second times the derivative of the first, which is 1 dx dx. Okay, so going in there, we can take away the dx's because those are just ones. So we get 3x squared plus 3y squared dy dx is equal to, and let's go and distribute here, so it'll be 18x dy dx plus y. And now to finish actually getting the full derivative, remember a derivative is dy dx, it's y prime, so we want to isolate these two. What you could do is maybe let's bring them both onto the same side, let's move all the other terms around, and let's factor it out. So 3y squared minus 18x dy dx is going to equal to y minus 3x squared. Okay, and then just wrapping this up to finally get the full derivative, you're going to say dy dx is equal to y minus 3x squared divided by 3y squared minus 18x. And that right there is the equation to represent the derivative. And so if I was going to graph that, and then I said, hey, what's the derivative at specifically the point 1, then we would just come into this function and plug in x equals 1, and it would tell you the slope at that specific point. Okay, going on to example 2. Let's use implicit differentiation again to find dy dx for the following function. Okay, so starting out, let's take the derivative of the left side, so it'd be 3x squared dy dx, dx dx, because the variable in this part right here is the x, so dx dx is equal to, now we got the quotient rule, so it's the bottom times the derivative of the top, so the derivative of 2x is 2 dx dx, and the derivative of y, of a minus y, would be minus 1 dy dx. Okay, so bottom times the derivative of the top minus the top times the derivative of the bottom. So the derivative of x is 1 dx dx, and the derivative of 3y would be 3 dy dx. So we're always taking the derivative with respect to the dependent or the independent variable, which is x. All of that over x plus 3y squared. Well, we don't really need the dx dx's, because that's the same thing in the top and the bottom, so they're all gone. And then we just have to kind of keep working with this. So 3x squared is equal to x plus 3y times 2 minus dy dx minus 2x minus y times 1 plus 3 dy dx all over x plus 3y squared. And here on out, we're just trying to do steps just in order to isolate the dy dx's. So if we multiply, both sides of the equation, just get rid of the x plus 3y quantity squared. Let's multiply both sides by that so we can just get rid of the bottom of the fraction. Okay, and then from there, how about we just go about distributing along the top, I guess? Okay, so we'll get 3x squared times x plus 3y squared, and then foiling over here, so 2x minus x dy dx plus 6y minus 3y dy dx minus, I guess if we want to, let's go and change that to a plus and distribute some negatives in there, so that way we don't have to worry about carrying the negative as much throughout everything. So negative 2x outside would be negative 6x dy dx plus y plus 3y dy dx. Okay, and I have several terms here that have dy dx in them. Let's see, there's one right there, one right there, one right there, and another one right there. Anything common? We have a negative 3y dy dx and a positive 3y dy dx. And we have a negative x and a negative 6x, so a total of negative 7x. Okay, so I'm going to come kind of cross into this next example's problems, but we'll come back. We'll finish this out. So x plus 3y squared is equal to 2x. I guess I can go and clean up the 2x's too. I was just focusing on the dy part, but I just now noticed we got 2x there and a negative 2x there. Okay, so let's finish this up. So we have a negative x dx dy dx, a negative 6 of them, so a negative 7x dy dx, 6y plus y is plus 7y. Okay, let's move that term over, divide off that front, and we can get our answer. So 3x squared times x plus 3y quantity squared minus 7y all over a negative 7x is equal to dy dx. Box that up, and then we're ready to start plugging in values. And notice how this time my slope, in a sense, has both an x and a y value in it. And so what that means is that whenever they want us to find a slope, they can't just say, okay, find the slope at x equals 1. They would actually have to give us a coordinate. They would say, find the slope at negative 3, 2. And that way we can plug it in and actually get the full value of the slope.